The periodic table is an extremely orderly arrangement of the elements, and it was developed in 1869 by a Russian scientist named Mendeleev. And what's really fascinating is Mendeleev, though he is given credit for the development of the periodic table, at the same time that he was working on organizing the elements, another scientist, who was a German scientist with the last name of Meyer, was also working independently on the same idea of how to organize the elements. And they both came up with a pretty similar arrangement of the periodic table. And what we have today, Mendeleev is actually given credit for this arrangement. Now, the periodic table I'm showing here has got a lot more designations than what we will need to know. But some of the things I want to point out to you: the stair step. This stair step separates the metals, everything on this side of the periodic table, these are all metals, from the nonmetals. Everything to the right of this stair step, those are classified as nonmetals. So that's one thing that's important to know. The metalloids, the elements on either side of this stair step, those are classified as metalloids. And we know things about metals. We know that metals are good conductors of heat and electricity. Metals are malleable and ductile, which means they can be shaped into things, into tools, copper wiring, pots, pans, etc. Nonmetals do not have those characteristics. Also, the metals that you see here at the center on this periodic table, they're in pink. They're in a different shade of blue on the front cover of your book. These are known as transition metals. Okay. The periodic table is numbered across the top, and there's different sets of numbers. There's the one set that goes straight from 1 to 18, and another set that is a 1A, 2A, 3A, etc. One of those is a European way of numbering the periodic table. The other one is IUPAC. The 1 through 18 is the IUPAC. It's the International Union of Pure and Applied Chemistry. That they set rules for how to name things, how do we label things, and typically the IUPAC is what the system we're going to use. But these numbers are known as group numbers, okay? So everything in this column, these are all elements of group 1. These have a special name. Group 1 elements are known as alkali metals. The elements of group 2, starting at beryllium at the top, down to radium at the bottom, these are known as alkaline earth metals. And we've already covered those shown here in pink. Those are all known as transition metals. Group 16 here, these are known as chalcogens. Group 17, those are known as halogens. And group 18, most people know the name for group 18. Group 18, those are known as noble gases. Okay, if we go back and look again at the elements on either side of this stair step, okay, we label these things on the left as metals. And it's important to note that metals tend to lose electrons in a chemical reaction. They lose their electrons. And since electrons have a negative charge, if we're losing some of our negative charge, then what that's going to do is make the metals end up with a positive charge. So metals typically can end up being a positive charge, and positive charge species are known as cations. So metals can lose electrons. Nonmetals, on the other hand, things here, not noble gases, okay, but these nonmetals tend to gain electrons. And so all that we said about metals is opposite here. If they gain electrons, that means they're going to have a negative charge because they're going to have an overabundance of the negatives, and nonmetals can often be known as anions. Let's look at some of the information that is contained within each block of the periodic table. Okay, there's different numbers. The numbers at the top, 1, 2, 3, 4, 5, 6, those are known as the atomic number. The atomic number, that tells you how many protons an element has. There's, of course, the symbol in each block, and it's very important that you learn the symbols. We don't have time to look up what is the symbol for magnesium. If we're working with a compound that contains magnesium, we need to know that magnesium's Mg. Also, the numbers at the bottom that you see in the periodic table, those are the atomic mass. That's also known as the mass number. The atomic mass or the mass number, that's the protons and the neutrons are responsible for that number. Not the electrons, because the electrons, they are so light that adding electrons or having electrons taken away is not going to change the mass of an element. Electrons are 1,840 times less by mass than a proton or a neutron.